All right, the focus of this video lesson is side-angle-side triangle similarity. And our theorem is theorem 8.5, the SAS similarity theorem. It says this: if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. So as we see here in the image that angle X and angle M are congruent, and that sides ZX over its corresponding side PM is equal to XY and over its corresponding side MN. If this is the case, then we say that the triangles are similar. So let's take a look. You're building a lean-to shelter starting from a tree branch, as shown. Can you construct the right end so it's similar to the left end using the angle measure lengths shown? So what we're going to do is we're going to first note the angles. We can see here that angle F is congruent to angle A. Now, in order to show side angle side, we must also see if FG over AB is congruent or equal to FH over AC. So we're going to check if FG over AB is equal to FH over AC. If this is true, then we would say by side angle side, these triangles are similar. So let's go ahead and check. So FG is 6, AB is 9, FH is 10, AC is 15. Reducing the first fraction by 3, we see that it's 2/3. Reducing the second fraction by 5, we get 2/3. Because these are equal, we know that the first statement is true, and then we could see, like I said before, the congruency in the angles. Therefore, we are going to say that triangle FGH is similar to triangle ABC. One thing you need to pay close attention to is that the corresponding angles, say A and F, are lined up in the same position, and the matching other sides and angles must also line up. Explain how to show that the indicated triangles are similar. Pause the video, give it a try. All right, so similarly on this problem, we'll note that we have this congruency with the angles. We see that R is congruent to N, and then we simply need to check that ratio of corresponding sides. In this case, SR over PN, and then RT over NQ. For SR, we have 24. For PN, we have 18. For RT, we have 28. And for NQ, we have 21. The first fraction we see reduces by 6, so it becomes 4/3. The second fraction reduces by 7, so we also get 4/3. This is true, therefore that initial statement is true as well. All right, that's it.